All right, well, we'll do introductions first, and then we'll dive in. My name's Aaron Sorensen. I'm the CEO of the Aromatic Plant Research Center. I've been involved in essential oils for a little over a decade now. My background is in chemistry and material engineering, and I actually am currently pursuing a PhD in biochemistry through the University of Miami. And I've done quality control, product formulations in cosmetics, dietary supplements, flavors and fragrances, and I've focused exclusively on essential oils for about the last 6 years now. And so my business partner and I, Dr. Satyal, we've owned APRC for about 2 years now, and I'll get into a little bit more of what APRC does in a moment, but I'll let Prabodh introduce himself here, and then we'll let everyone give a chance to tell their names.
Probably everybody knows I'm Prabodh Satyal. I got my PhD in essential oil chemistry from University of Alabama in Huntsville. I'm originally from Nepal. I came US to pursue PhD degree. Before coming to US, I was lecturer in Kathmandu University, Nepal, and I got master's degree in chemistry in Nepal. I came here, I got another master's degree and PhD degree, and since then I'm working in industry like from 6-7 years with Aaron. And we thought, there is need of, very strong lab on adulteration detection. And we come to idea, let's do ourselves, none of the lab are working on adulteration detection. And we are able to, formulate this lab. And I do research on essential oil, especially adulteration focused. And day-to-day activities of, APRC, I'm involved on that.
So the things that we'd like to cover today, and again, this is very fluid depending on what questions you guys have, but we've done introductions. We want to talk about what essential oils are and where they come from, some of the distillation there. We'll also we'll go into our lab and show you how the primary unit we use for testing essential oils, which is gas chromatography mass spectrometry, GCMS. We'll show you how it works. We'll let you prepare oils, and we're actually going to have you guys test oils using GCMS today, as it says on there. We'll also get into the aroma and chemistry of essential oils, and how your nose is actually a very precise instrument in being able to detect different chemical compounds that you probably smell every day and just you're used to it. You don't realize, that's what that is. And so, and then we'll review an analysis. Actually, the test that we'll have you guys run today, we'll then go through and review that analysis and see what the chemistry is of the oils we'll look at today. And then we'll talk about adulteration. As Dr. Satyal said, that's one of our primary focuses. Why it happens, how it happens, and how to detect it. And that really is at the core what got APRC started, and we've branched into doing just a lot of research on essential oils, education, as you can see, in essential oils, and we do publications on a monthly basis. We probably publish 2 or 3 peer-reviewed articles a month at this point, and in the field research, sustainability projects. It's really grown very quickly, and it's been a lot of fun. And then any feedback or final discussions from you guys too. Okay? Questions? Perfect. So what is an essential oil? So let me just throw that out there. You can see what we've got written up here, and you can see in your little booklet. But if someone came up to you and just said, well, brand new, what is an essential oil? Do I put it in my car? What's an essential oil?
So oil excreted from plants? I don't know.
Good. No, that's not bad. So it comes from plants.
Usually put it on you topically.
Okay.
That's what I'd say.
Great. Good. So the science, or the technical definition, they are natural aromatic. What that means is they easily go into a gas. They become volatile compounds that are found in a variety of different types of plants. So they are produced naturally by these plants for a lot of different reasons. And it does take a lot of energy for the plants themselves to produce these oils, so they always are produced. There's a reason that they do it. A lot of times it's to either help attract insects for pollination. It can be to defend, is a lot of what essential oils, what the plant uses for them, and hence why A lot of times it can be useful for not just humans, but even animals will brush up against plants because they found the bugs don't come around when I'm around this plant. And so it is some kind of, it's a pollination, attraction,
Communication.
protection, communication. Plants can also let each other know there's a form of speaking to one another through the different oils they produce. So, and they are very antimicrobial, so it helps to protect against diseases and various funguses, molds, other microbes. And there's also evidence that it can help to prevent some water loss in more rural, dry areas. So not all oils, first of all, not all plants even produce essential oils. There's only what are known as aromatic plants actually produce an essential oil. And those then plants that do produce an essential oil will be various yields or how much they'll produce. And a lot of it can be, again, it takes energy to produce an essential oil in the plant. And so if there hasn't been a lot of need, if they're naturally endemic to an area where insects don't attack them, or temperature, they can easily communicate or attract pollinators, and they just don't need to produce as much, they won't. But a lot of it too nowadays is you can get into genetic selection. So if producers are, if a strain or like an oregano, like you said, if they can continue to, whether it's genetically engineering or just doing selection of different plants that naturally produce more oils and propagate those. So that's a lot of it today is for larger scale production is they'll naturally select plants that then propagate them that are found to produce more of the essential oil they're looking for.
That's why Melissa is expensive over oregano or other oil, because it has lower yield. Like even rose oil has lowest yield, right? The most expensive oil.
Yep. Yep. So a lot of it's just naturally, it just doesn't put in the energy to produce that oil, and there's a very low yield on some of them. Some less than 0.1%, and so you got to get literally tons and tons of raw material to get just even a minimal amount of essential oil. Okay, I wanted to show this here so you can actually, so if you look at the peppermint leaf there, if you do magnify in, the essential oil is, at least on leaves or on flowers, it's in these little sacs. It is contained in there that can easily be broken.
Like here, like in the orange.
Yeah.
If you peel it, you see these are oils. But normally oils are produced by steam distill or hydro distillation, but this is cold pressed, right? So if, ISO has defined if essential oil has been produced by steam distillation or hydro distillations or by cold press of citrus oil, those are called essential oil. If you extract by using solvent or CO2, they are not essential oil. So here is one good example. This is essential oil, whatever I'm squeezing, that is essential oil. This is cold pressed orange oil. And see, you can see the glands are here, and they are, this is limonene. You can, you already have smelled things like that. So this is a very good example of essential oil.
That's perfect, yeah. Have you guys ever, when I was a kid, used to take the orange pill and like take a lighter and squeeze the orange and it flames up out? That's the essential oil being expressed.
And it has
from
highest
that
yield because you can easily get lots of orange. You see oils.
You can actually physically
that's why it is cheapest oil.
squeeze out, There's a lot of it produced with all the fruit in the world, but if you squeeze it, you can physically get oil out of a citrus rind. Yep, that's exactly it. The only one I could see in the oil sac, the only one I've been able to see with my naked eye was in Australia. I was there with tea tree, and you can see it has little leaves. They're probably just 3 or 4 millimeters long, and you can look them and you put up to the sunlight. You can actually see the little sacs on the tea tree leaves.
Here also you can see a little bit.
Not quite as transparent there, but yep.
So that we can say that most of the essential oils, they are flammable?
They can, if you put them directly to a flame, they can flare up, but not like gasoline or things like that. Yeah, it's not. But yes, they would be more flammable than, well, of course, water or things like that. But just because there are different functional groups with essential oils, there are alcohols that are contained in them, esters, and so yes, they can produce a very brief flame if you actually put a flame right to it. But general storage, like, don't be concerned if you've got lemon oil, even so orange oil in your house. You really would have to put a torch to it to get it to flame up. So there's very minimal concern with flammability with essential oils. But for large storage, I don't know if you guys have experienced this too, where you do need to have proper storage because they do have a lower flash point than some general glycerins or things like that you may be used to. So there are precautions, especially if you're in bulk storage of essential oils. So as Prabodh mentioned here, I wanted to just talk a little bit about how we get these essential oils from the plant's end. And as he said, ISO, or kind of the international standards, defines an essential oil as something that is either distilled or cold pressed. There's a third category that we'll get in there that are extracts. It's a much broader group of aromatic materials. So distillation is the method where steam is directly injected into the plant material, and the heat and the rising of the water, the steam molecules itself, will help separate the oils from the other material that it's on, the raw material of the plant there itself. And then, so as you can see in this little here, so if you've got a still, this is a representation here with the plant material, steam injected up through. So the steam and the oil itself in a gas phase will come down through a condenser. And typically it's a container, and we've got a still outside we can show you too, that cools this steam back, it condenses it back into a liquid and the oil there, and so they'll come back down through. And so the water and the essential oil goes into a separator. And because they are different polarities and different weights, typically the essential oil will, as it settles, will rise to the top of that separator while the water sinks to the bottom. And this water actually does still have remnants of the plant material. It's called a floral water or a hydrosol. And that there are still uses that. A lot of times they're used in cosmetics because they do still have different properties. It's not just water anymore. But the oil itself does separate out. There are times where the oil settles on the bottom. It's heavier than water. And so there will be dual separation columns depending on what you're doing, to where you can dispense the oil from the bottom of the container or the top, depending on how it's specific gravity for water. So, good. And there are several different types of distillations. We're actually going to go into our wet lab here soon and show you a hydro and steam distillation. Hydro means that the material itself is actually in the water. You mix it together with the water. Frankincense and other resins, that's very common to where you have them all in one container and then it all evaporates together. It depends on how long you run. So the longer you run it, obviously the oil will continue to be taken out of the raw material. And so at the beginning of the process, there'll be the highest percent of oil coming through because it's still all in the plant material. As it goes through, some distillations go for days, some go for a few hours. So by the end of the run, where most of the oil has been taken out of the raw material, it'll be mostly hydrosol, mostly water coming through with a smaller amount of oil. And so in bulk productions, they'll get to a point, and I've seen some very sophisticated distillation to where it's actually where when the yield gets low enough of the oil has come out of the raw material to where you actually would be losing money continuing the distillation because of the energy put into it. I mean, you got to heat water up. You got to put a lot of energy into this process, and so it can be very expensive. And I've seen some very sophisticated distillation setups to where it's electronic and it can tell you, okay, you're putting more energy in than oil you're getting out. It's actually costing you money to keep running, and it'll automatically shut itself down, and that's the end of the run. The differences between different qualities of oils, yes, can definitely be influenced by the type of distillation and how meticulous the distillers are in the process. But usually the big quality difference comes after this, to where it goes to a broker, what's added to it, how is it stored, things like that. So really it definitely can, if you just burn it, you let the water run out, you can just burn the material, and I would bet some of you maybe not, but I've smelt a lot of oil that it smells like it was like you left the cooking pan on and all the water evaporated and it just fried it. So yes, if you don't do distillation properly, certainly impacts the end oil. But a lot of times it's pretty straightforward. If anyone who knows what they're doing, you can get a decent quality oil from distillation. Okay. And as Pramod talked about with the example with the rind here, so the other process that is still considered an essential oil is cold pressing or expression. And this is most common in all citruses. And so citrus oil is actually a byproduct of the juice industry or the food industry. You can think of all the millions and millions of pounds of fruit that's produced through the world for food all over the world, juices. And so a lot of these companies, they'll produce a fruit juice, and after it's juiced, that rind or what's left over goes into a pressing process. And so it's either a corkscrew like this one, to where it physically presses the oil out of the raw material itself. So there isn't there's no steam injected, it's not heated up like this. That's why it's called cold press. It's not that it's cooled, it's really room temperature versus the 212 degrees Fahrenheit it takes to distill a traditional leaf or steam distillation. And then as it's pressed through, this oil comes out of the rind and is collected. It's then cleaned up. There's still a lot of waxes. You can get heavier components from this process. And that's where orange oil, lemon oil, bergamot, all those come from this process here. And then this excess plant material goes into, most of the time it goes into either becoming a fertilizer or goes into the feed industry for different cattle. So cold pressing in the citrus industry is really a cool process because there's zero waste. Every bit of it's used. And so you in the end, you get at least three products: the juice or the fruit itself, the food, the oil that comes from the rinds, and then anything left over can still be reused too.
With citrus oil, do you get more oil when it's compressed versus steaming it?
Actually, you can do both. So you can still take the raw and steam distill it, and so you can get what's called a distilled lemon oil or a distilled orange oil. You actually get about the same yield.
Okay.
So the processes are almost equally efficient in pulling out the amount of oil.
And what will be the difference in between one distilled and one cold pressed with the citrus oils specifically?
Yeah, great question. Because this is more of a physical process, you get additional components in there, heavier components. And so if you look at like a cold pressed orange oil will be orange. It'll have some of that orange pigment in there, where if you do a distilled orange, it's actually completely clear. So yes, there are small chemical differences. For the most part, they're 99. Furanocoumarins are a good example. So like in bergamots or certain types of orange, there are chemicals that will react with light. They're called furanocoumarins. And you should be mindful of those too, using topically. If you put a cold pressed, especially a bergamot, on topically, and then you have contact with light, a chemical reaction takes place, and it can actually cause a chemical reaction and start to...
Photosensitive, right?
Photosensitive, exactly. So there is not that same, those furanocoumarins are heavier components, and they don't come through in this distillation process. So that's why you can use, if you're going to make a topical blend, and you may be in the sun, things like that, use a distilled or a furanocoumarin-free version of citruses. Good question. The final one here is, and I just kind of put extracts in general, and there are dozens, hundreds of different ways to produce an extract. And so it is a similar process. You take the raw material, but then you put in a solvent. It could be hexane, alcohol, carbon dioxide is another good example. So if you've heard of CO2s, that's what these are. So it's taking some sort of solvent, mixing it with the raw material, and then evaporating that out or having it come together. Even in everyday tea, like if you're steeping a tea, you got your
water extracts.
Yep, water is the solvent in that case when making a tea. And so you can get down and then you can take all that solvent out, which a lot of times that's hard to do. In instances, it's a challenge to get 100% of that solvent out. So that's where the difference can come in. Most of the time, the solvent is still present in the finished product, even at very, very minimal quantities. Except for something like a CO2, where the carbon dioxide we're breathing right now, all you do is you condense it, put it under a lot of pressure till the carbon dioxide becomes a liquid. mix it with the raw material, take the pressure off, all that carbon dioxide goes back into a gas, and you're left with your finished raw material. So that's probably the most clean extraction, and leaves the raw material closest to the starting material. And there's different processes to where once you do this solvent extraction, evaporate off the solvent, you've got what's called a concrete. You can then have it go through another wash. You put an alcohol with it to get more of those waxes and things out, and it can come to what's called an absolute, is one of the most common extraction.
Floral extraction.
A floral extract. So if we look at here, so if you could, let's say that these are all, just for demonstration's sake, these are all orange. So you can steam distill orange and get a distilled orange, cold press, get a cold pressed orange. You could take orange rinds and do a solvent extraction and go through this process and get an orange absolute. And so it really is, the only difference on those is the process used to obtain them.
Do you say the process of extraction is the purest?
Well, not necessarily the purest, because it depending on the solvent you use,
Right.
that solvent can remain. You're actually adding things to the raw material. And so that's where steam distillation of these here, the water does not interact, it's not part of the end product. Where the solvent can remain.
Unless you put it under pressure.
Unless you're doing, so that's a very specific one. The CO2 is probably the cleanest in that regard. Now, other considerations with this though, because let's say that these oranges were collected and they've just been sprayed with pesticides and things like that. There's a much greater tendency for those solvents to take those pesticides too. And if you're, even with the CO2, you release the pressure, those pesticides are still in this end product too. So it can happen in here too. So that's another, just things to be mindful of.
Like heavier component comes out those two processes, not
Yep.
that one.
Yep. So, and please tell me if you have other questions too. But an absolute is more of, it's got heavier components in it. The things that won't volatilize and come over through distillation will be present in absolutes, and so it's thicker. It would be almost like you can get like cakes or a piece of chocolate is what an absolute can come out like. But especially this concrete, it's this thick cake. And then you can wash it and get more of but it's still a very viscous. So you can tell, you can see the difference in an absolute versus an essential oil.
Which is the cheapest one?
Good question.
Which has the highest yield, right?
The highest yield is definitely the extraction here, especially where if you're going to use a very cheap solvent, an alcohol or a hexane, that you're not really concerned if it remains in this end product, and so it can go into some cheap air freshener or something like that. By far, this is the least expensive. They're the cheapest because these solvents can be very, very inexpensive, and you still get the smell at the end. You can say it came from it's naturally from orange or whatever, but you do need to be mindful that whatever solvent they may have used here could be toxic, could be harmful, could be unpure itself. If they're just going for absolute cheapest production, you need to be very careful. That's a perfect example. So if you go and look at those flavoring aisles, pick up almond or lemon, and it'll say alcohol is the first ingredient. And so actually it's got more alcohol in it than the lemon itself. But so it'll still, it's kind of like if you've heard the term, a tincture too. So it's just pulling out those flavoring components in that. But the first ingredient isn't the raw material itself in those. So very good. So let's now with that, let's go in to the wet lab, and we're going to show you distillations that are taking place right now. And then we'll come back and talk some of the ways we test essential oils. All right, if you guys, so follow me into the wet lab here. How are things looking? All right. I wanted to introduce you to Dr. Nora Dasoki. She's our research scientist, and she oversees a lot of the distillations that we do at APRC, but also we have LCMS, which we're going to talk about in a moment too. She oversees that. And this is our micro lab here. We do various just general micro testing, but we're getting into different activities of essential oils and dosage and things like that is what Nora's done for a very long time.
So this setup here is a hydrodistillation where you have the plant material with the water in the bottom boiling flask, and then both of them boil. You get the steam carrying the oil, goes through a buffer zone and then to the condenser to condense again and become a liquid again. And here you have them separated in the oil separator. You have the oil on the top and the hydrosol on the bottom.
What kind of plant is this?
This is frankincense, and that's how it looks like before that.
No, resin.
It's a resin and it's chunky. That's why we put it in hydrodistillation, because it needs to melt. The steam distillation wouldn't be able to penetrate through the whole chunk of resin, so hydrodistillation works best for the frankincense.
You guys see the oil sitting on top? You feel free to
Yeah.
come in and get close. It is
It's
hot, just don't touch
Right
it.
here. See that? If you see it here too, this is the oil and that's the hydrosol as well.
That is what at the bottom? This is water?
No, it's not water. It's like the soluble molecules from the volatiles that came with the steam come in with the water. So it's not only water here.
Okay, awesome.
And it's like they say, it's really important with, or it's matter from where it's coming. For example, the reason if the pen is coming from east or the west or whatever,
Yes.
you will receive more compound.
You can, and that's one of the things that we research is even the same species, like frankincense. Well, there's different species of frankincense, but if the same species is growing in different regions, yes, you can have chemical variations. And that's one of the things that we research, why we do so many distillations, is to say, okay, even during this season, harvested at this time in this specific region, this frankincense, for instance, but add any plant material there, produced this specific chemical profile. So it could change each year if there's a big drought, if it's overly rainy, if there's other influences, if it's colder, if it's hotter. All those things impact what the plant is going to produce.
Yes, and even if it's an agricultural crop or something that you plant yourself, the practice you use, the fertilizers, anything you used will affect the oil as well. The other setup here, that's steam distillation. It's the only difference here is that you have only the water and the boiling flask in the bottom, and that boils on its own and gives the steam that goes through the material in another flask. And then the steam goes up with the oil to condense again here to another liquid, and you have here the oil on top again and the hydrosol on the bottom.
And what is
Some-
that plant or what is it?
That's a cardamom.
Cardamom.
Why is the water?
So the water is colored because all of the water is coming up, but then some of it is condensed on the material and comes down. So not all of it goes through. Some of it carries some of the oil, some of the color, and goes down. So that's why the color is different.
So that's steam,
That's steam.
and
This is hydro.
hydro.
Yeah.
So hydro, you think, of course, hydro water, it's the raw material with the water together. Steam, where it's really just the steam going through the raw material of interest.
In some cases, you will have the oil drop down below the hydrosol, so it will be on the bottom, not on the top. And a good example is clovebud, and that's easier to collect actually from the tap here. But in these two cases, you will have to collect from the top.
And so in the frankincense, usually you distill it for more than 24 hours. So there's much more oil that will come out of this.
So
And this is not even commercially scale. Commercially scale is done in like 1,000 kg.
Oh my God.
Yeah, yeah, huge. Yeah, so it will take time than this small scale. Yeah, yeah.
Yeah. And we actually just did some study at one of the distillers we work with, took samples. He distilled for 5 days. Is that what Plowman did?
24 yeah.
So,
More than 5 days.
so he was taking samples every 5 hours or something?
24 and then 10.
Yep. So took samples throughout just to see, okay, how did it affect the chemistry? And he then mapped out all the yield differences because he's like, I can just keep going and oil keeps coming, but how does that impact the chemistry? And it was interesting. The lighter components got less in the later samples, but it wasn't as dramatic as I thought it was going to be.
Really?
Yeah.
So you got fairly consistent yields.
Well, the yields, yes, went way down. but the chemistry stayed pretty similar. There was differences, but the heavier components were more prevalent in the getting towards the end of the distillation, and there was more. The lighter stuff comes off first.
Okay, that makes
Yeah,
sense.
like a low boiling comes first, and heavy boiling comes later on. That's like a normal, common sense.
Okay.
But so he's in a very rural area, and it's not like in the U.S. where it's very expensive. He's like, if I'm getting oil, it's not costing me a whole lot to just keep going. So he may distill for 5 days on his frankincense. Something big like lavender, it's produced everywhere in the world. Once you get to 4 to 6 hours, after that you've got it all. So.
You could get more non-volatile,
Right.
little bit, non-volatile, but it would not be economically, feasible.
Yeah, like
Yeah.
what you said.
Fuel
like,
cost
it will
matters.
cost you more to produce it the way
Yeah.
you get.
Exactly. Yep. You guys want a piece of frankincense?
Yes.
So you can see, well, you can take whichever one you want, but like this one here. So it's just like on a pine tree. So if it gets damaged, or that's what the Boswellia tree does to protect itself. It secretes this resin to fill up a hole, or
So that means it's a healthy tree.
yep. And so if you score it, is what it's called, it'll naturally produce these resins that have been used for thousands of years in religious ceremonies, and it's a very, it's used in the Bible, it was a gift to the Christ
Very
child.
spiritual.
Yes. And so you can see like some of this, it actually ripped off some of the bark as it was harvested. And usually, so this is probably a lower grade resin because they'll go through and clean it off better, so you don't, that's just wasted weight. You're not going to get oil from the bark. But you can still smell, so you look at a big piece, yeah, feel free, yeah, if you take any you'd
I
like.
know the bark was to look at.
And so you can still smell it on there. This resin's probably a couple years old now too.
Oh, wow.
But you can see where if you do steam, it's just not going to be able to penetrate a big blob like this. So you do, once you get it into the hydro, it melts it all, lets it get to the center of these resins and pull as much out as
So is
possible.
it the water that breaks it down or the heat?
Both.
Both, okay.
Yep.
Together.
Yep. So if you put this in water, it'll get sticky, and you'll start to break down.
Okay.
And you can try that too. But typically, like if you've seen an incense burner, you could just put frankincense on a burner and just set it on there, and it'll start burning off.
Oh, wow.
Yeah, just
So I could go home and try that.
yep, yeah, just set it on a little burner, put it on your stove, and you'll smell that frankincense start coming off of it.
Can I take two?
Of course, yeah, take as much as you want. We get samples from all over the world, and we have to end up getting rid of bags of it because we don't have anywhere else to store it. So,
Just send me a message and I'll pick it up.
you want to come pick it up for us?
I'll just take your trash.
Okay. Good. You guys can have some too. I don't know if you
I
guys
took one.
did. You good?
You want me to?
This is the oil used for your star you were talking about.
Oh,
Yeah,
it
this
is?
Yeah.
Oh.
Most expensive kind of, or one of the expensive oil.
Okay, that's cool.
Yeah.
I didn't know this is what it was made out of.
For which one?
So
Sorry.
it helps
So
scars.
use
Oh,
frankincense
yes.
to remove the scar, or
And so if you think too, and so APRC's focuses on the plants themselves and the oils and analytical testing. As far as end use, none of us are medical doctors. We do provide information that's out there in the community and do research or communicate research that has been done on that. But our focus is not how these interact with people. But I mean, yep. Right, exactly, and we're all before it gets into a bottle, we do research on everything up to that point. But it does make sense to where, this is what the plant uses to protect itself, ward off insects. It's been wounded. It's how it heals. It's like a scab. So it could make sense if, without getting into studies that I haven't done, that's why frankincense can be helpful for scars, other things topically like that, because it's a natural means for a plant to heal itself. All right, let's go back into the conference room. Would you mind? Because we'll go into the analytical room next and prep samples. Thanks, Nora. So let's talk about some of the ways to test essential oils now and why we do that. So liquid chromatography, mass spectrometry, is a method that we use to, it's very good at detecting pesticides in various aroma products. Again, especially if you're looking at extracts or expressed oils, ribosome-based oils, we can look and see that. That's really one of the main things that it can help with. What it does is it keeps the oil in its liquid state, and you can run it through through a column, and then it determines its mass. I'm trying to keep this, it can get very complicated, but just kind of keep it simple. But very basically, it does tell you it can identify specific components. If you're looking for a specific pesticide, a specific heavier component, LCMS is very adept at being able to say, yes, this is identifying that component precisely and the amount of that component in the sample you're looking at. And so for CO2s or things like that, to where they are in a solid or remains in a liquid state, they don't go into a gas as easily, LCMS is much more useful for that than like a gas chromatography, which we're going to talk about. Yep, because it keeps it as a liquid, and so you don't need to heat it up to get it to go into a gas to be able to detect it, like in gas chromatography. Yep. So anyway, so vegetable oils, carrier oils, things like that are LCMS is useful for doing testing on those because they don't evaporate very readily, and so we don't need to evaporate them using liquid chromatography. Okay. Now, physical constants, this is kind of the gold standard, or it's been used the longest in testing essential oils. And we can show you, this is a picture of it's called the Autoflex here, but it really is, it tests the physical properties, characteristics of the sample you're looking at. And so an essential oil, as you shoot a beam of light through it, or again, any sample, you take its optical rotation, the amount at which that light is turned or bent, excuse me, not bent, it's polarized, it's rotated. The amount it rotates it will be very specific for a sample and its chemical makeup. And an optical rotation can give you that exact number. So it really is just a number about how much it rotates light. So it's, again, the rotating the optics and what that does with light. And so it's very useful with the FDA. So I have a quality control background, and so being able to verify if you've got an oil or any sample, it should be in a very specific optical rotation range.
To know the components?
To know if you're trying to say, hey, this is peppermint oil, a peppermint oil will have very specific optical rotation.
That is so cool.
So, but if you test a lavender oil, very different optical rotation.
So you'd have to know that rotation.
Correct. So it's all built on history. So and again, this has been around for a very, very long time. So it's very well documented where those results should be. Now this is where the limitations of physical constant testing is. You can add components in to adjust, so that you know as a producer, if you want to be falsify things, you know where it should be, and if you're going to add components that take it out of that range, you can add others to put it back in that range, so you can play with it that way. But it does happen too, like you can have a very natural peppermint or whatever the oil might be, that if it's a drier season, it was naturally produced where it could end up being outside of that range, but you really haven't done anything to it. So those are some limitations. It's more of an indicator.
Right.
And honestly, for us, it's just more historical. It's what people expect. If manufacturers are saying, well, we need it to meet this physical constant, can you test physical constants?
Did that come about because way back when, is that how they used to test it?
Yep. That was the most sophisticated means to do it 60 years ago, 70 years ago. And so, yeah, so large history. So we know exactly where it should be, except for instances where it naturally does fall out, and that happens. Refractive index is similar, but it's how it bends the light. So you kind of put these three tests together. Specific gravity is its ratio to water. If it floats on water, it's less than 1. I think frankincense is about like 0.91 for its specific gravity. Methyl salicylate is like 1.02 or something like that, to where it'll sink in water. So
so it refracts. Okay.
Well, I'm sorry, so specific gravity,
Oh, sorry, okay.
like if you literally put the oil in water, It'll float if it's lighter than water.
The density.
It's density, exactly. And so with all these things, and so it's multiple layers of, once you get so if all three of these are in line, it's a good indication that, usually it's used just for identification, that yes, if it meets all three expected profiles for peppermint, it's probably a peppermint. Whether it's pure or not, this doesn't tell you that. But it's still kind of a historical tool to be able to identify an oil.
So do you guys use these tools ever in your testing every time? Or
Not every time we offer it to all of our
Okay.
clients, but for someone like a doTERRA, yes, they do this on every single sample, building up history there. We have our client, we offer it, but again, our focus is adulteration detection, and you can get more information, in essence, everything this will tell you, our GCMS will tell
Yeah.
you in more depth
More accurate.
anyway, so. Anyway, so it's more of a historical. So GCMS, this is really the bread and butter, again, because we're talking about volatile compounds. We're talking about what an essential oil is. It's things that very easily go from a liquid to a gas. So they can smell, so they attract, so they protect. And so gas chromatography is ideal for testing essential oils. And so using this method, there's really two parts to GCMS. The gas chromatography part is really, as you can see in this animation here, I'll let it run through a few times, but it's just a long column. It's a tube. We use a 60-meter long tube that as you inject an oil, a very small amount of the sample, you heat it up at a very consistent rate. They're big ovens, basically, and so you can control exactly how much you heat it up, and so you know the speed at which everything's coming through, and the lighter, smaller molecules move the fastest, just like in a race. Go through the column. Heavier molecules take longer time to come through, and by the amount of time it takes those individual components to come through the column will give you a really good indication of what the component is, what the chemical is that came through. So that's called its retention time. And there's big libraries too that can tell you the expected time based on your ramp heat, your heating ramp, the pressure you've got your gas pushing it through. It can tell you exactly what the chemical is. And so this detector, this is called a chromatogram. It gives a peak every time something comes out of the column. And so it gives you, if you see like those, looks like a topographical map, if you've seen a GCMS report, that's the machine's interpretation of the data it's getting through. And so it really is very helpful in being able to be specific in exactly what chemicals are in that oil. Now the second part, which amplifies your ability to detect the amount, but specifically what it is the mass spectrometry. So by its mass, and it goes into this detector, and it's ionized, or it's broken apart, and just like if you've got a Lego set, and it's always going to break in its individual pieces. Would be extremely rare for a Lego piece itself to break in half. It's going to break between the individual pieces. Same thing with chemical components. As you hit it with ions, it'll break apart in a very specific fragmentation pattern. And so by the way it breaks and the masses of those individual breakups gives you more information about the structure of this compound and being able to identify it. So it's more complicated
Probably
than that.
you will see in the machine we are going to do practical. It looks like now chemistry. Oh, what is Aaron talking about? Probably, sometimes you guys may get scared, but when you go and do practice, oh, this looks easy. You will feel that.
Yep,
It's
exactly.
coming
So,
soon.
so we'll go into the lab and show you all
Yeah.
this physically too, which help. But conceptually, this is how GCMS works. Oversimplifying it, GCMS separates all the individual chemical components in a sample and identifies them. So depending on if you use proper methods and if you have experienced chemists, you can literally see every single compound in an essential oil. Honestly, you could take an oil to any lab, even that has GCMS, and they can analyze it, and yes, you're going to see the major components. You'll see linalool, linolyl acetate, lavandule acetate in lavender, very easy to identify. That really doesn't give you information about is it pure. It is those very minor components, because when you produce, and we'll get into this more too, as you produce synthetic lindyl acetate, it's never a 100% accurate process. There's byproducts of that chemical production process. Those byproducts are what we term synthetic markers, and they can be extremely minor, parts per million, even parts per billion in a sample, but they do not occur naturally in an oil. So
That will pick them up.
this will pick it up. Yep.
Yeah, and those are called synthetic markers.
Yep.
And those which you cannot synthesize, those are called biomarker.
Yep.
And by looking over synthetic marker and biomarker, we look over adulteration. We don't look over major component like menthol and 1-8-cineol and say, oh, this one is pure because it has 40% in a menthol. We are not going to say that, but that's the indication of adulteration. Besides than that, we do other things also.
Yep.
Like a chemometric testing.
Yep.
Yeah.
And so it is, it's all those, and so we look at, for every sample we test, we look at more than 1,000 components. Because again, it's not those top 30 or 40 that will make up 90+% of what actually is in the oil. That doesn't tell you the story of it's pure or not. You got to look at the bigger picture. Everything else, that the steps that would have been left is someone's trying to build an oil or make more profit for themselves. There are indications, and whether it's the biomarkers are reduced, the synthetic markers are there and increased, clear indications that this is not a pure
I feel like a
oil.
lot of companies would alter things because they're producing it, so.
Yeah. What happens most of the time, because essential oils are produced in very rural areas, and again, we'll get into this more too. We actually will talk specifically about adulteration here in just a moment. But a small farmer who, this is his year's worth of crop, if he can add 10-15% castor oil and get 20% more yield from his farm, I mean, you understand why this happens. What happens most of the time is these brokers, these consolidators will buy from these small farmers from all over the world, consolidate it in, and then they are the ones who are expert at producing even natural chemicals. Those brokers will sell to the end users of the products. And most of the time, 90+% of the time, those end buyers do not know that what they're buying has been adulterated. It's not currently. Again, because it's all, well, no, you're buying peppermint with menthol in it.
To expose.
Yeah, right. So most of the time, for any, like a general lab, we'll you do a GC-MS run for about 30 minutes. And so allow it for 30 minutes to separate out. We run ours again because we're not really focused on those major components. We run ours for at least 100, usually 110 minutes. So more than double. Because again, you think of all these thousands and thousands of components in a sample, the bigger picture you get, the more they separate out. The easier it is to identify them and to really see a much bigger picture of what's really in that oil. So our run times are far longer than nearly any other lab, and our expertise in being able to identify unknowns, things that other labs have never seen before. They don't know what it means to actually find these components, but we do. Sorry, I don't understand your
For
question.
example, we have a peppermint oil,
Mm-hmm.
and it's coming here, I don't know, 1,000 of different compounds.
Yes.
And we have menthol.
Yep.
Now I say I want to break menthol, so I put a menthol back,
Mhm.
only menthol, and I break it again. Then you guys do it?
Well, so if you're talking about, so one of the things, and to answer your question from in there before, so you can still, just like, so if you've got your raw material, peppermint leaves, and you distill it, really what you're doing is just, you're separating the oil from the other raw material. You can distill again, and so separate out, and so you can choose sections of distillation, so you can just pull the menthol out. And so that's what you can take and then add that to other components. So there's isolation of individual components. Now, we don't necessarily, so we can identify the menthol, but it's not the menthol that will tell us if it's been added or not. The other components, so like when you're synthesizing menthol, do you know what's a synthetic marker for menthol? Is there?
Paramentin for all Cs.
Yep. And so when you do a synthesis to menthol, you'll get maybe 99% of it plus is menthol, but paramenthine cis is also produced at maybe 1%, less than 1%.
0.01, something like
So
that.
it's extremely
Very trace.
small. we've gotten very good at knowing what to look for in which oils, like what's the common practice. But so then, but we do also know what should be there and what shouldn't. So this is where expertise is everything. And so, yes, it's the method you use, it's the equipment you use, the times that you run it, but being able to go in and know what is that telling you, looking for synthetic markers, and that we've identified. A lot of times, most other companies don't know that those even exist. They've just never paid attention to it. And so it's not necessarily the menthol that we'd focus on or break down, it's the byproduct of menthol production that we're looking for to prove that peppermint, there's no biological pathway for peppermint to produce that chemical. It is very readily produced in the synthesis of menthol in this process, though. So
that way it'll be more recognized?
Mhm.
Is that the purpose of your guys'?
yes, so that we can prove and say, look, no, we know X component has been added because of this marker, and also again, as you add something to it, everything else gets reduced.
Yeah.
So the overall view of the profile of the oil is what we look at. So that's why it's important to run it for long times, have experts in knowing what to look for, or else it's very, very easy to miss adulteration.
And nature is a great chemist, than human being, synthetic chemist. Nature follows, or biosynthesis follows only 4 or 5 pathways to give all the molecules, whatever molecule, there are like 10,000 molecules of essential oil that can be produced through only 4 pathways. But if you do synthesis, you can use any chemicals or anything to produce that molecule, right? And during that synthetic process, you will get unwanted compound also, which you cannot avoid because of their boiling point and retention properties. You cannot remove that marker out. So by looking over that trace marker, it's like a 0.01, sometimes very trace, like Adam says, parts per million or something like that. We look over those marker, and they all the time try to make pure menthol or pure chemicals, so that they can make people will get confused. Oh, how do you say my oil is impure? And we say on the basis of impurity or synthetic marker. So those synthetic marker indicates you have played or not. And nature is all the time, like a very perfect chemist. I told you, it only produces whatever we expect. If it comes out of the track, something has happened, and we figure out, this has been produced by this way, or by the sometimes you do hydrodistillation or steam distillation, you get some unwanted products, something like that. It should be like a justifiable to some extent, yeah.
But even things like that, so if it was just done because you used hydro versus steam, those still we can, Probode is good enough to know like those chemical pathways to say, like, okay, well this, even though it's not typically present in this oil, this is how you can see they just used hydro instead of steam. So it wasn't an intentional adulteration or even something malicious, but this is what caused these
So
components to receive.
you can see if it was.
Yeah, if it is out of biosynthesis or not.
Yep.
Yeah.
Yep, exactly. It's a lot like if you ever watch Forensic Files or being a CSI detective, if someone's going to come into a room and they put their hand on a door, they leave DNA on a doorknob or things like that. And it's like, no, I was never there. It's like, well, why is your DNA on the doorknob then? That's some of the things that we do is like, why is this synthetic compound in your peppermint if you didn't add anything to it?
Sometimes I don't like the results because you go so deep that you can really find the traces.
Yep. Yeah. So just like in every aspect, science gets better, and you can get more in tune with being able to gather little details and tell a bigger story.
I might not have gotten this correctly, or probably you just answered. But
Sure.
it's just like, I mean, when you were talking about menthol, like you don't know, it doesn't tell you about purity because you can have, you can isolate menthol and then just add it to something.
Right.
So, but you can't see if the menthol was synthetic or natural.
Yes.
You can see that.
Yes.
The difference. So it'll go just like, oh, these menthol was synthetic.
Right.
Maybe
Yeah.
synthetic.
Yep.
Okay.
Yep. Again, through those little markers, the other details, little footprints that are left during a chemical reaction or other processes, that's really what we're looking for. It's
Like we know most of the, what you say, bunch of companies over the world doing essential oils,
Mhm.
you know, means which percentage of companies they do it like changing, the compounds, or they're not 100% pure. I mean, it's a bunch of companies doing that way?
Well, and I think you got to understand it's all about context. I mean, it's easy to tell part of the story, but for hundreds of years, I mean, really, aromatherapy is new comparatively.
As research.
As far as research and even just, people, essential oils exist because of the flavor and fragrance industry. They've been used, it was Gros, France is the birth of essential oils because it's where perfumes were made. It's where it's all just fragrance based or taste. And so they weren't really, it wasn't therapeutic in that sense. And so, yes, it wasn't malicious to try to reduce your costs, to try to extend supply, and just try to, but that's, and so that's what was readily available. I mean, all these huge companies, Firmenich, Givaudan, that are billion-dollar companies that have been around for hundreds of years. This has been their business of supplying, and customers are asking for it. I don't want any smell difference or any variation from batch to batch. Well, the way you control that with a natural product is by adding isolates and building it to be exactly what you want every time. So it's not really this, dark man behind the scenes. Yeah, thanks. Oh, sure, yeah, you got both of them there. Thanks. And so, but then so there's, I mean, tons and tons and tons of these perfumes and other things that are being produced for hundreds of years. And then all of a sudden, I'd say even in the last 20, 30, whatever it's been years, people are wanting, okay, well, I'm going to use it as more for medical benefits and things like that. This is what's readily available. This is why essential oils are even readily accessible, is because of the flavor and fragrance industries. And so again, it's not that it was, I don't know, I keep saying malicious, but ill
It
intent.
just depends on what you want it for.
Right.
You have clients that want certain things.
Yep, exactly. So again, if a new, let's say I start my own essential oil company because I want to share the benefits that I've seen with them, and so I go to a big flavor and fragrance company. I'm growing. I need to buy a ton of lavender, and so that's all I tell them. Like, yeah, sure, great. We'll sell that to you. Here's $50 a kilo, and if you're not being specific and saying no isolates, no synthetics, it's got to be entirely pure, and I'm going to test it to ensure it's pure. They'll be like, I mean, they're selling this lavender, hundreds and hundreds of tons of it to many other clients. They won't even ask a question. Just be like, yeah, sure, I'll sell you a ton of it. And then you buy it thinking it's lavender, real lavender, and sell it. Yep. So it really is, most of the time, the end seller is unaware of what they're buying because of just ignorance is too strong.
Because there are more chemists than essential oil producer. I think so.
Yeah.
So they know how to make more profit, and they try to cheat you, because you are innocent. You don't know chemistry, but you know how to sell. All right. So.
And a lot of times too, as a business owner, I'll shop my market. I'll go and say, hey, I'm looking for lavender. Company X tells me they can sell it to me for $50 a kilo. Company Y is going to sell it to me for $175. I'm not even going to look at. I mean, I might not even ask. Well, you're just crazy. I can buy it for $50 over here.
So do you know why is it required to be able to label 100% pure essential oil?
There's no requirement.
Really?
No regulation.
No way.
No requirement.
Oh.
And I think that's where it'll get into. Again, it takes legislation and laws times to catch up and things like that. But I mean, there isn't a way to prove that. That's really where we're coming in. Yeah. So you can put anything on there, and yes, there's ways you can sue for label claim. If companies, especially if you're comparing with another company or something like saying, we've got the exact same oils as company Y. And company Y can test and be like, no, you don't. You're selling synthetic aroma chemicals. We're selling real essential oils and we can prove it. That's where lawsuits and things can come into place. But as far as regulations, as what's in there from a government perspective, nothing. People generally will just, like I said, they'll email us all the time, tell me which companies are pure. And it's like, well, no, that's the proprietary. Our clients pay us to provide that service, and we'd break confidentiality to just give you that information.
Right.
But yes, if you want to collect oils and become our client, send them in. We will give you the results.
What is the price?
How much is it to cover?
Our standard, so GCMS, and again, we do other things as well. Our standard cost is $200 per. Mhm. Yep.
Do you need to do both the GC and the Aspen?
Yes. Yeah. So and it's all one, and actually we'll go in there in just a moment. It's all basically one unit. It's kind of two parts. So yeah, it all happen. You can just do GC, but again, it's not nearly as useful in identification. So yeah, so when there are labs, they'll say yes, we can run a GC on it. They might mean literally just GC.
GCFID.
Yeah, so there's different detectors too.
Cheaper type of instrument and less information. So it is going to see only menthol, methyl acetate, neomenthone, only those what you want to see, and it won't see what you don't want to see, like synthetic marker, biomarker. You don't see from GCFID very clearly. Yeah, so that's why GCMS is the most preferred and the most powerful instrument of all over the instrument what Aaron talked about. So for essential oil analysis,
So cannabis is an aromatic plant. It does produce an oil, and it has unique compounds called cannabinoids, and whether that's CBDs or THCs, there's dozens of them. And yes, we have clients who sell cannabis products. Yep. So it is newer, but there's a lot of peer-reviewed, very well-done scientific information that's showing here's the benefits of using. Again, there's dozens of different kinds of cannabinoids. Obviously, THC is the hallucinogenic part, and so it's like with anything.
What happens when you mix it with, for example, cannabis, the CBD oil, and you mix with, I don't know, lemon?
Mhm.
What's going on? I mean, it's changing.
It's a good question. Because you can, if you have and that's one of the other cautions with adulterated oils. If you're adding synthetic component or even natural components, you're reducing all those other thousands of components that naturally occur in the oil. Who knows if those components are actually what's giving you some of the therapeutic benefits you've enjoyed with lavender or peppermint. So, and as you mix different things together, again, I don't know. It stands to reason that as you have a broader chemical profile, they may interact with you personally. It could be different person to person too. So it just makes it more complicated.
So in general, we can say that you reduce the good benefits. We can say.
Potentially.
Potentially.
We don't know that. But again, so like menthol rub, what's a Vicks Vapor Rub, like that literally just has menthol in it. And you can see it opens up your airways.
I had seen some research on synthetic versus natural chemicals, and they found definitely enantiomer synthetic has both enantiomer D and L, but natural has only one. So if you use both enantiomer, it will have different biological activity over one. So what are you using for peppermint? Synthetic peppermint may do some other effect on your body. So that research says I had seen some paper on synthetic linalool, synthetic menthol, linalool acetate, and they tried on two different groups, pure versus synthetic, and pure had different effect, in psychologically, and synthetic has different effect. That synthetic was not kind of desired one. Probably I don't remember that article right now, but I remember what is written there. If you need, I can send you a reference of that also. Yeah, I mean it will have effect, enantiomeric effect.
Yeah, it stands to reason. Again, your body can smell the difference between enantiomers. There's just very slight chemical differences. So it makes sense that how it interacts in your body to how your body uses it could be different too. So like I was just to finish up, and then let's go show you some GCMS here. So like Vicks Vapor Rub uses us, and I don't know if it's natural or synthetic, but it's just menthol. It opens up your breathing ways. It's actually a drug. Menthol is considered a drug. Now, if you get it in peppermint, and peppermint's been used a lot to alleviate headaches and things like that. Is it the menthol that's doing that? I don't know. Is it everything else? Maybe. Is it a combination of everything else? Maybe.
Or D-menthol or L-menthol.
Right.
There are two types of menthol exist, D and L. So in peppermint, normally you have L-menthol.
One of the great things about we've almost had like this a 1,000 million year experiment of people just trying different plants and just kind of evolved and naturally like, well, when I take this, it helps me feel better for this. So we've kind of got this evolutionary, this human study going on, and we don't know exactly the whys. We're still figuring those out. But it'd be like, yeah, when I use frankincense, I healed faster, whatever, you know. The why it works and what's actually doing it from a chemical perspective, we're still learning a great deal about. But again, our ancestors have been doing this for thousands of years, and it kind of just naturally got down to, well, this worked for this ailment. Now we're trying to catch up on the whys. Okay, excellent. Very good, I like it. Thanks, good questions. Let's go do some GCMS. If you'll put your lab coats back on. So this is our analytical lab. And so you can see the units here that we just talked about. And Phil, again, ask any questions you'd like.
So this is GCMS, and it's a Shimadzu brand. It's a QP2020 model. And this is GC unit, this is MS unit. GC means gas chromatography, MS means mass spectrometry. So by using those two units, we analyze oil. What is in oil, how much in oil. GC helps in knowing what it helps in separating the oil component. MS tells what is in oil and how much in oil. This is called detector. And some people have GC FID. FID is detector. How much is going to told by F detector. Like here MS is going to tell how much, what is. Also, GC also helps on that process. And GC, this is called injector port, and this is auto sampler unit. And you put sample here, and you assign in your computer what sample has to be run today, and it picks out, it keeps here. You will see that when you keep your real sample. We are going to run those two real sample, but I'm just telling all the basic principle. And this is auto injector. Here is a syringe, you can see here. It's like a, you can see syringe here, and syringe will take the sample and inject in the system. And here it's called injector port, and it all the time works in very high temperature. It has temperature 260 degrees centigrade on this DC. So when you inject the sample, it automatically goes to the gaseous phase. So when it goes to gaseous phase, it needs some kind of carrier oil. It has to be gone through column. It has to travel long distance so that they can separate into individual component. So here is injector port. It has 260 degrees centigrade temperature, and there is a helium gas, carrier gas, that will inject the compound down to the column. It will move, it will take a velocity. And here is a column. I think Aaron already told, it's a micro, very thin capillary column. We do have some column there, right? And it has like a diameter 0.25 micrometer diameter, very, very thin. So the gas will push through all the way. It's 60 meter long column. We use longer column because it is more efficient over shorter column. So those gaseous compounds keep moving around, and whatever the lowest molecular weight, smallest, will come out the first. And it is connecting with MS side. When it goes to the mass spectra.
So actually, so this is actually a 30-meter column. We use one that's twice as long to get more separation, but that's actually a tube. It's that small. Wow. So it travels through this. Again, it goes full 60 meters.
Travel, 60 meter travel.
This is the short one that we don't use.
Yeah.
So all the components go through this tube, and as they go through it, they separate, and that's how we can identify them. So that's a gas chromatography column.
But when the sample runs over, any smaller component comes first, and the time when it comes in, we run like 110 minutes methods. Like alpha pinene comes about 14-minute method. All the time alpha pinene comes at 14 minutes, and menthol comes about 35 minutes. So the time is all the time constant. And by looking over the time, and when that molecule comes here, electron bombards. Electron breaks down molecule into several pieces, and that piece is all the time unique. That signature is all the time unique, and that is called mass spectra. Looking over that mass spectra and retention time, we identify molecule. So that's the way it works. And you guys are going to run this. You guys are going to prepare sample and run in the system. And I will tell you how do you analyze oil here, and it's going to be very interesting. So here is oil that was distilled recently. This is cardamom oil.
being distilled this morning.
This is frankincense oil distilled over there. So you guys, we don't have so many GC. So you guys work in the group, all right? 2 groups.
Are there 2 people that would like to prep a sample to do? You want to prep volunteers? We got one here. Do you guys want to fight over it? So yeah, so let's do 2 here. So so let's grab some gloves. Put some gloves on. So these units are so sensitive that actually we're only going to use 7 drops of oil. To do a run, we only need 7 drops of oil. And then the GC, actually, it does what's called a split. It splits off, what is ours, like a
24 to 1.
a 24 to 1?
24 parts of injected things goes to the pods,
Right.
and only 1 part out of 24 is injected in the column.
Yep.
And by the helium gas push it down all the way,
Yep.
and you separate and you see the components. You'll see that.
Right.
Yeah.
So a very, very tiny amount of oil actually goes into the unit.
So you said how many?
So what we're going to do, so we actually need to dilute, because these units are so sensitive, we dilute with a product called dichloromethane. Now we know exactly when this comes out of the column. It's very light, it comes out first, and so we actually just cut off the first couple minutes of the report, because it's all the dichloromethane coming off first.
Oh gosh,
Yep.
that comes
Yeah.
out really easy.
Yeah, it's a very light molecule, so even just the suction from the bulb, it can come right out. You just try to squeeze the whole thing in there, because you might need to do a couple draws. So, so that's the dilution that we're going to do to each sample. So now, if you want to do the cardamom here, and if you want to do the frankincense,
And how much?
so what we're going to do, we're going to take this, and so we're going to take the top off here, and I'll explain these vials in a bit here too. So we're just going to put 7 drops.
Okay.
Okay. So just pull that up. So just get a draw on it, and then
Okay.
just hold it over it. Can you brace your arm on the table, and then just put 7 drops
Okay.
into the bottle.
Sometimes we use micropipette to exactly measure and put in there, so that you don't need to count drop. This is like for a normal purpose.
The old-fashioned way.
Yeah.
Perfect. So, so we've got these with their dilution in here. You want to major thing to make sure is you mix it up, because the oil will just sit on the top of that
They actually
dichloromethane.
mixed up with that solution.
Yep. So it'll mix up now with the dichloromethane. Make sure that's all mixed together. And if you can see these caps, they're puncture caps. So you actually do just in the carousel, we line up our samples, and then the syringe will go right through the top of the cap, draw the sample exactly how much the unit needs, and then go over and inject it into the unit.
And this is the position number 1 when you are going to put sample. Put here, like in the number 1, and 2, 3, 4, 5, 6, 7. It goes in that way. So you put number 1 here, and in the vial number you put 1 here. If you are going to put 5, put the sample here. All right, and then sample name. What is that? Frankincense or cardamom. And you put the lot number. You can put today's date as a lot number, and SAP number, just forget that, and it will be the same. And you choose the method here. We have like for this class we made a very short method.
Yeah. So for time's sake, again, typically we'll run at least 110 minutes. We're just going to do a quick 20-minute run, because we know it's pure. We distilled it ourselves, so we're just going to look at the major peaks. So actually, two other people want to come actually input these into the system, and we'll start the run. You want to come try it? Yeah. Great, Kristen.
And then you put the oil name here,
So
and
if
then
you want to run
select
through
it,
for
run
both.
it.
So let's do both of them here.
Yeah, sorry.
Now, what I was talking about with when you harvest the raw material, that can have an impact on the yield. But as far as once you've got the oil finished, yeah, these units, so these carousels we set up. So again, it's about 2 hours each run, each test. So we'll set up dozens of samples in the morning, and then they'll just run all day and all night. It'll automatically just run through. Yeah.
And our machines are most of the time busy. Like we run like 10 to 12 samples per machine. We have 7 machines. More than 7, yeah.
We got more than 100 samples yesterday, and so we just wanted it, so like they could have been running. Once you shut it down at anyway, we waited for this class to be able so we could do these runs, and then we're going to start running these samples this afternoon.
But machines are all the time busy. Even on the weekend, they are working on.
Wow.
Yeah, they can run up to 150 samples at one batch table. Put the 150 samples and go home and come by next week or after 10 days.
In theory.
Your data files are ready, and then you have to crunch the data. You know, it's not like the other machine. You have number, it comes up. You have to look over all the peaks very carefully, and then you come to know if this oil is good or not. It goes in this way. So it takes time here. It takes with the analyst also. Analyst will also take time to analyze the sample, and then our reviewer will take time. It's like and then we have like a three-layered reviewer. Once analyst does, another reviewer see, and another reviewer see, and then only we send report to our clients. It's like several steps.
Definitely. Well, let's let these run. Let's go back into the conference room. We're going to do a little bit of smell test now, see how good your noses are at picking out things. So I want to just talk a little bit about the aromas of essential oils and how it relates to the chemistry. So one of the most common components of essential oils is linalool. And it's this is the chemical structure of linalool, and you can see, I don't know comparatively how much chemistry background you guys have, but it's really a very simple compound, small. Yep, it's a monoterpene alcohol. This is isolated linalool. This is just pure linalool. I want you guys to smell this.
How did you get that? Synthetic or?
I think it's a natural linalool, actually. So this is from Howood. Yep. So if you guys wouldn't mind taking one of those and pass it around.
And probably you guys already smell linalool somewhere in some oil.
Yeah, and then so as
You'll feel
smell
that
it, let me
when
know
you smell that.
what I don't know what feelings. What does it remind you of?
So we don't know what this is?
No, it's linalool. It's pure. It's an alcohol. Yep. But so, what does it remind you of? Anything that comes to mind?
It reminds you of Howood oil, lavender oil, basil oil.
lavender.
Yeah.
That's what.
Okay.
That's what it is for me.
So as you can see, so what I want to do now is a comparison.
Smells like a cleaning product.
Yeah, and that's what's interesting as you get the individual component. You're right. It smells unusual or.
How basil would smell? So like basil in the oil, if you put it on you, you're not gonna smell like an Italian salad, are you? Like
Sweet basil. I mean,
Oh,
I already
okay.
told you.
Okay, so
Yeah.
depending on the basil.
Yeah.
Okay, that makes sense.
If you put other basil, it smells different.
Right. So this is lavender. The main component of lavender is linalool. So compare these two. So see if you can pick out the linalool in it, and then smell and see if you can pick out linalool in lavender.
Lavender is usually mixed with linalool.
Linalool.
Yeah,
linalool.
that's one of the major constituent in lavender.
So yes, it
So
does.
that's why it smells.
Yeah.
Okay.
It does naturally occur, but again, this is where getting into chemistry and adulteration. So lavender, depending on the year, it can cost anywhere from $70 a kilo up to $150 or more a kilo. You can get isolated linalool, even a very pure, for about $30 or $40 a kilo. So if you want to boost your linalool in a lavender, you can add so that's where you get in, and so it's naturally in there. So can you smell the similarities between the linalool and the lavender?
More flowery.
To me,
Yep.
it smells a little bit.
So and actually, so citral is the main. So it's actually citral is an interesting one because it comes in. There's actually two components that always make up citral, geraniol and neral. It's just a different configuration on this double bond, and there. And you're right. And so it's the main component of lemongrass, melissa, and actually it's a minor component in lemon, but it's probably that's what most people associate it with. There's usually 3 to 5% citral in lemon. 60, 70, 80% citral in lemongrass. So
Litsea kibeba and then lemon myrtle. That's Australian oil. Yeah.
so here is
That is like 90% citral.
Oh, really?
Yeah.
so this is lemongrass. So compare the two there.
Yeah, it's pretty much the same. Yeah, it smells.
Yeah, so it should be So again,
It's in between lemon.
yep. So that first one I gave you on this round is it's 100% citral. That lemongrass is probably 70 to 80% citral. So it should be very, very similar with other minor components in that lemongrass. Again, citral, you can actually, there's products like a Litsea cubeba that produce almost a very pure citral component, so that can be isolated, very cheap. And so, so it'd be closer to a Melissa. In fact, I do have a Melissa.
That's why the citral doesn't have a color, and lemongrass is little yellow color.
Yes, yep, exactly. So lemongrass does have a little bit of color to it there.
Yeah, so when you guys smell, something like lemongrass, then there is citral. Like when you get Litsea cubeba or lemon myrtle, oh, it smells like lemongrass, but you don't know the oil name.
Citral.
There is citral, so you can say, oh, it has citral.
Yep.
Yeah, like,
That makes sense.
yeah,
That's a good way.
yeah.
So this is Melissa. So I happen to have a sample of Melissa with me too. Melissa. So it should sell very similar. Again, so what you can see, if I've got lemongrass, which is $12 a kilo, I've got Melissa, which is $1,500 a kilo because of the extremely low yield.
It is now $1,500. Oh, I was thinking $3,000.
It's come down. It has been up to like $3,000 in the past. And yeah, Melissa is not my favorite. It's got a little bit of a ting on the back of it. I don't know
Melissa
how to
or
describe it.
lemongrass is not favorite.
Well, both.
Both are good.
I like Litsea cubeba is really almost pure citral, and it tastes just like lemon heads. It smells just like lemon heads, and I really like it. But you can see you got very cheap lemongrass. I could even just sell it as Melissa, unless have a lab that knows the chemical differences of those minor, looking past the citral. You could get taken for 100 times what it's actually worth. Okay, so limonene. Anyone, what do you think limonene is present in? Limes, very good, yes.
Orange. We recently prepared some orange oil.
Orange.
Yep.
Okay, so
Also in spearmint you have lemonade, right?
Say that again.
Spearmint.
Spearmint,
20%.
That's a little
Carbon, limonene, not the major one. Carbon is the major component, but limonene is also second major component.
actually, the interesting thing about spearmint, carvone is the same component in oregano. Caraway.
Yeah.
So caraway and spearmint have the same component, except they're different enantiomers. Just like it's just a different configuration. Just like your hands, like your right hand can't fit on your left arm, it'd be backwards. Those are actually the same components in caraway and spearmint, but they're just in different configurations. So, but your nose can pick that out. I mean, that's as different as those two are. That's how chemically similar they are.
In any races, like for trees, like cypress or whatever.
So limonene.
Trace, could be trace, 0.1,
Limonene is
0.2.
probably one of the most basic structures. It's probably in every single essential oil at some amount.
Highest is in the orange oil or grapefruit oil, but bergamot also has limonene, and lime, lemon, all has limonene.
Why is bergamot so different than the other citrus?
It's a genetically engineered fruit.
Oh, it's not natural. Oh.
Well, it's a crossbreed. It's crossed
It's
between.
like government.
It was produced for the flavor and fragrance industry, but it is a cross between like oranges, grapefruit, and other things too. So it actually.
But it has molecule like lavender and lemon.
Yeah.
If you mix both of them, it looks similar in chemistry.
Yeah.
Yeah.
So this is orange. This is a navel orange specifically. There's dozens of different variety of orange as well. But yeah, see if you can. You should be able to smell the limonene pretty drastically in orange as you compare.
Orange.
That's orange, yep. But honestly, again, your nose is a very powerful tool. There's times where you can get to be like, something's off on this, and you can start to detect adulteration with your nose. Again, that's not perfect because there's a lot of chemistry ways to fool your nose, but you can get really good at being able to say, something's wrong with this.
Like for example, if somebody has added carrier oil on your oil, how do you test? Paper-based testing. You know that?
no.
You don't know? Okay. when you put in a adulterated oil or carrier oil or heavier component mixed oil,
Okay.
when you put in the paper, like the filter paper or something, it won't evaporate all out, like even for 3-4 hours. But if oil is pure, that will evaporate out. Yeah.
Okay.
So this is like a common people's techniques. Like common people, those are users. They don't have like a sophisticated instrument. Chemists, they cannot afford. So they can look over density. They can look over paper-based testing. They can smell and tell the oil is pure or not.
Cool.
Yeah, those are kind of very easy. Anyone can do, and that works sometimes.
Any paper do it, or it has to be specific paper, or just napkin or what?
Just any paper again, because it's kind of the principles where the volatile essential oil, it'll evaporate fairly quickly. You got a heavier carrier oil that like a coconut oil or a vegetable oil, it'll stay on there. It's not going to evaporate as quickly.
Try a
So-
put up the drop and see. And if you want to compare two companies also, you think, oh, this oil is pure from this company, and I would like to use this company's oil, and try both in the paper and see which one get vaporized earlier. And you can think, oh, this company has.
Now I'm gonna be going home.
Yeah.
Purer.
Yeah.
The faster it evaporates, it's pure.
Yes, but again, it's all about label claims. I mean, you want to, oils are very potent. I wouldn't recommend putting neat oils on because you can get sensitivities, and so a lot of companies will sell in a carrier oil already, so you can apply it. Again, you should apply it that way. So, yeah, but if they're claiming it's 100% pure, untouched, just the oil itself, and you can see it doesn't evaporate, something's
How
in
we
there.
work on that, the filters for the coffee,
Mhm.
the paper filter.
Uh-huh.
How is that paper?
How is
To
it?
do it, the test, like he said, if I put it.
You could put it on it'd be
Is that
good.
paper good? I mean, it's like.
Actually, that would be a good. It's just all about getting to where the oil can separate over a surface area and evaporate. So yeah, a coffee filter would be a good one to do that on.
Okay.
Yep.
So with your, sorry.
But just be careful with that too, because like if you're using something like an orange or a lemon, and so it's got a little bit of color to it. If that color stays, that could just be. It doesn't necessarily mean the oil's adulterated. So you got to see is the product staying on, or is everything evaporating on except for like some kind of pigment. So we've been talking about throughout the day adulteration, which again is what we specialize in. We want to just kind of get a little more map it out here. We've talked about why adulteration happens. Usually it's always economically motivated. You can make a lot of money selling adulterated oils.
Like you can make rose oil from lemongrass. They have the same components. Yeah.
Oh, so you couldn't detect if it was actually lemongrass, just plain.
We could do that, but people make in
You
that
could,
way. But you can make $40 to $10,000, like at how much fold? 250 fold.
So if you're gonna put a lot of money into it, that's when people.
Yeah, you make lots of money.
Yep.
Yeah.
And so if you're really wanting to know what's in there, that's where our expertise comes into it. And again, it's not. I don't mean to say that those things are all bad. Like there are some products where that's the right thing to do. Like it doesn't make any sense to put a $10,000 rose in a Wix air freshener. Yeah. So, but if you want a rose scent, there's a variety of ways, even to do it naturally. Again, so it's not that we're saying there's evil or it's bad or things like that. But if you're trying to say, hey, no, we've got pure rose essential oil in this air freshener, I really doubt it if you're selling it for 20 cents. Yeah. So different types of adulteration. As we talked about, one of the very most common is just add a carrier oil to it. And one of the things that, especially in today's methods where GCMS has kind of become the gold standard for seeing everything, if you've got a heavier carrier oil and you're not running your method long enough, it doesn't run long enough to actually see the carrier oil. So, yeah.
So it becomes an adulteration when you state that it's 100% pure rose oil and you're adding a carrier oil.
Yep.
But if you're diluting and you're stating that it's diluted, it's not necessarily an adulteration, right?
I agree with that,
Because
yes.
it's because of the claim,
Correct.
not because of what you're putting into it.
Exactly. So it's all about being upfront, being honest with what's in there. And again, some of the people that actually selling it really don't know, and not that takes all blame away. But yes, if again, it's appropriate to add a carrier oil to a finished product if you're going to say just add this finished product topically. But a lot of times what will happen, especially lemongrass is very common in very rural parts of India. castor oil is very prevalent.
Or
all
cooking
over the place.
oil,
Cooking oil.
vegetable oil.
Vegetable oils. And so you can fool a lot of the brokers because they'll just do a quick test, run, even if they're doing a GC, run it for 30 minutes. That carrier oil never came through the column. You cut it off too quick. And so you can extend your product 20, 30, 40% just by adding a very cheap carrier oil. So, and then so synthesized components. And so there's really two types, and this is really Probode's realm here. So you can produce an essential oil that actually never came from plants. You can take, there's millions and millions of tons of cast off from the petroleum industry, petroleum byproducts, that you can take that raw material, phenols and other things that come from gas and oil, and through pretty simple chemical processes, turn it into just about any component. Methyl salicylate is a really good example where wintergreen is hard to produce. It's can be uncommon, paying a couple $100s for a real kilo of true wintergreen that again is almost entirely methyl salicylate. You can produce it through using byproducts of petroleum products, about $5 a kilo. Smells exactly the same, would pass GCMS and all ISO, but you can tell through carbon dating it's actually 7 million years old, not 2 years old. So there's ways to detect all that too. But it's very common to do completely synthesized chemicals. And you could take, again, lavender. You can synthesize linalool, linyl acetate from petroleum-based products. Add those in very cheaply. Pad your profits, even make 100% profit by adding petroleum-based products into it. So very common practice. The other side of that is you can use natural precursors to build those. So the paper industry, in that process, during the turpentine process, alpha-pinene is one of the main products or byproducts of the paper mill industry. So it's natural, came from trees in the mill industry. And you can take that alpha-pinene and either just use it and add it to frankincense. Again, $2 or $3 a kilo. And you can add it to a $250 a kilo frankincense. Huge profits.
You're basically producing the oil.
Right. You really can. In fact, we've done this before at any of our conventions. We've actually fully built oils. And we'll present them and be like, here's the real oil. Or just say, here's 2 oranges. Tell us which one's real. And it's hard to tell. One that we completely built in the lab or one that was actually...
That's why you have to go through the smaller peaks in order to
Exactly. So
understand
that one we built will be missing all biomarkers. So it'd be very clear to us, but you can fool your nose. If you're not doing proper testing, very easy to fool. So again, and so even with the terminology that they can use, say like, this is an all natural essential oil. That could be true. Is it completely pure? That's another story, could be another story. So even the terminology that you use with people there. So, and so natural isolates. So you could even take, as we talked about, really distillation is separating the oil from its raw material. You can then take the oil and I've been to facilities that they're called separation columns. It's huge versions of distillation units where all they're doing is separating individual components. It actually is like a huge GC. Like the GC, what it's doing is it goes through the column, gives time for all those components to separate. You can do the same thing.
Rubber band, probably you didn't tell that.
Yeah, the rubber band story, to where you can, as you separate it out, you can see individual parts. Like if you ride on a rubber, you guys done this as a kid?
Yeah.
Maybe today still. You take a rubber band.
It's like a strips,
Yep.
but in the normal form in the oil, it is like a...
Yeah, so that looks black there, but as you stretch it out, it'll get white and change color. So as you can see more detail as you stretch it out. Anyway, so you can take essential oils and isolate them in huge separation columns. So if you just want to pull the limonene out, if you just want to pull the citral out, and so it actually may even come from that same oil, but you can boost products with the other components. But most of the time what will happen in natural isolates is you can take something like a hoe wood that is less expensive. You can just isolate the linalool and then add that linalool from hoe wood into lavender, bergamot, more expensive oils. So,
And make more profit.
yep. So it's all about making profit. So again, and again, this is, some industries are, yes, I want you to do that because I want to pay half the price and it's still natural. It still meets my expectation. It's consistent. I don't want to have to guess where the smell is going to be on my next batch of lavender. I want it the same every single time. That's the way to do that.
Or the demand of it too.
Yep, yep. So that'd be another way to tell, like if you're seeing differences in oils you buy from various companies, like it doesn't smell the same as my last lot, that's not necessarily a concern. It'd be like, nature varies. It's not the same every time. So there was peppermint a couple years ago. There's huge droughts up in the Willamette Valley in Oregon, and you could smell the difference in the peppermint. And there was we had tons of questions. I don't know if you guys did too, but yeah, you could smell a big difference in the U.S. peppermint from that year because there was just it was a drought year. So fractionally isolated. And then kind of the final one we've got here is just adding a like oil. I gave the example of lemongrass, produced very ubiquitously throughout the world. It's very cheap, $15 to $20 a kilo. It's very similar to Melissa. Someone who's untrained, you could just sell lemongrass as Melissa, sell it for 100 times the price you actually bought it for. So, or you can add, so cassia is inexpensive, just add that to cinnamon bark at various amounts. Again, it's all about decreasing your cost and increasing the supply and being able to make more profit. So this is just a few examples. It's
Like lavandin is mixed with lavender. You know, we tested so many companies' oil from market. They had, you know, most of them had lavandin.
Yep.
You know, so lavandin and lavender looks chemically similar, except some few components. Like lavandin has higher camphor, borneol, 1,8-cineol, more than 1%, but in the lavender it is less than 1%. They look exactly same, even plant-wise. Probably you saw a lavandin plant
Yeah,
also,
the
right?
plants themselves look
Yeah.
very similar.
Yeah.
Yeah.
So they mix things like that, you know, similar
They
types
say
of things.
lavandin instead of lavender.
Yeah.
Yep. And again, there's nothing wrong with lavandin.
Yeah, but it's not lavender.
If you're gonna,
That's adulteration,
Yeah.
that's a claim.
So
That's exactly
cheaper version.
Cheaper
It's a
version.
cheaper version, yep. So if you're going to sell lavandin, and there's definitely uses for that, but if you're going to call it lavender, that's disingenuous. So,
But it will
that's
pass
where we-
ISO test very easily.
Yep.
You know, ISO test has this percentages, they will qualify that percentages also. So ISO test is not going to work even on that case.
Yeah.
And definitely if you add aroma chemical, it will definitely pass. But mixing similar oil is very hard to detect, you know, sometimes.
Yeah.
Yeah.
Because there's no synthetic markers, biomarkers will still all be present. It's all there.
So
It's just,
it has to be tested in order to even know.
yep.
Yeah.
And it's even a challenge. Like those are one of the hardest ones to detect, but there's still indications, things that are present in like lavandin and lavender, or cumin, not cumin. What am I trying to say? The cinnamon bark and cassia. You can just add cassia, but there's things in cassia that aren't in cinnamon bark, and vice versa. So you can pick out some of those biological markers in those different types of oils. So yeah. Good. So this is again just a very brief overview, and then understanding this and kind of the history of why there even are essential oils available today with the flavor and fragrance industries and their intents with the use of those products, why adulteration is so prevalent. And again, more than 80% of all the market samples we get, there's some issue with them. Yep. Questions? Good. Let's go back into the lab, and now we're going to finish up the analysis. Do you have any questions about analysis? I know this is quick and dirty here, and we're covering it. There's a lot of detail. We have over 8 chemists that this is what they do all day, every day.
I was wondering how you did the results so fast.
So you can. So the first step is just do a library comparison, but then you got to have an analysis go through, and because computers aren't perfect, and so you can go through and make any adjustments as necessary, and then so we'll have a reviewer review what the analysis did too, an analyst did. So yeah, it's a multi-step process. So the library itself, the analysis itself, and then a reviewer. Yep. And sometimes it'll go through a fourth as well. Yep. Well, thanks, guys. Any comments, questions, feedback, anything you'd like to see different? We offer these maybe about every month or so, just to the general public. Other things you'd like us to focus on or
Maybe
suggestions?
you guys did like a series sometime.
Okay. Okay, yeah. So our cores, we have 4 pillars. Testing, analytical testing, research and publications, sustainability in the field, and education. And so, was it, you want to add a 5th? Yeah, so this education piece is, it's really just, we enjoy it, we like what we do and want to share it with other people. So, good. Awesome. Well, thanks so much. Any other questions? Thanks, guys.